Implementation of BYD's Blade Battery Technology by 2024, for critical phases and a $1.2 billion investment in R&D. Introduction. BYD, a leading Chinese electric vehicle EV manufacturer, is set to revolutionize the electric vehicle battery landscape with its innovative Blade Battery Technology. Scheduled for implementation by 2024, this initiative is bolstered by a significant $1.2 billion investment in research and development R&D. The Blade battery aims not only to enhance performance and efficiency but also to redefine safety standards within the EV battery industry. Key features of the Blade battery. The Blade battery was launched to address the critical safety concerns associated with traditional lithium-ion batteries used in electric vehicles. BYD's chairman Wang Chuanfu highlighted the battery's robust safety features during the launch event. Key features include exceptional safety performance. The Blade battery successfully passed rigorous safety tests such as nail penetration crushing and exposure to extreme temperatures. In contrast to conventional lithium batteries, which can ignite at temperatures exceeding 500 degrees Celsius, the Blade battery's surface temperature only reached 30 to 60 degrees Celsius under similar conditions. This represents a significant advancement in battery safety. Optimized design for space utilization. The Blade battery's design improves space utilization by over 50% compared to traditional lithium iron phosphate batteries. This optimization not only allows for a more compact battery pack but also potentially increases the overall performance of the EVs that utilize it. Resistance to extreme conditions. The Blade battery has demonstrated resilience under extreme conditions, including being crushed, bent, heated to 300 degrees Celsius and overcharged by 260%, without igniting or exploding. This highlights the battery's capability to maintain safety even when subjected to severe damage. Implementation timeline and phases. The rollout of the Blade battery technology encompasses 4 critical phases leading up to its full implementation in 2024. 1. Research and Development 2023. The initial phase focuses on refining the Blade battery technology to ensure it meets the highest safety and performance benchmarks. This phase includes extensive testing and optimization of battery materials and configurations. 2. Pilot production late 2023, following R&D. BYD will initiate pilot production runs to test manufacturing processes and validate the viability of the Blade battery. This step is crucial for identifying any production challenges and ensuring quality control. 3. Full-scale production 2024. BYD aims to ramp up production capacity in response to anticipated demand for EVs equipped with the Blade battery. This phase will involve scaling up manufacturing facilities and workforce to meet the market needs. For market launch 2024, the final phase will see the Blade battery integrated into various BYD vehicle models. The flagship Han EV set for release in mid-2024 will be among the first to feature the Blade battery, showcasing its capabilities and performance advantages. Safety and industry impact. The Blade battery's emphasis on safety marks a significant shift in the industry, where manufacturers have historically prioritized energy density over safety. BYD's proactive approach aims to elevate safety as a core consideration in battery development. This shift could influence industry standards and practices, prompting other manufacturers to reassess their battery technologies. Moreover, BYD has expressed a willingness to collaborate with other vehicle manufacturers to share its Blade battery technology. Such collaborations could lead to broader industry transformations, emphasizing safety as a critical component of EV design and battery technology. Market readiness and competition. The Han EV, BYD's flagship model scheduled for launch in June 2023, will be the first vehicle to feature the Blade battery. With a remarkable range of 605 km and rapid acceleration capabilities 0 to 100 km per hour in just 3.9 seconds, the Han EV positions BYD competitively within the increasingly crowded EV market. The introduction of the Blade battery is expected to enhance BYD's appeal to consumers, particularly those concerned about battery safety and performance. BYD's commitment to safety and performance is likely to attract interest from other vehicle brands seeking partnerships. The potential for collaborative ventures could further strengthen BYD's position in the market and drive innovation across the industry. Conclusion: BYD's Blade battery technology represents a pivotal advancement in the safety and performance of electric vehicle batteries. With a clear implementation timeline and significant investment in R&D, BYD is poised to lead the industry toward a future where safety and performance are equally prioritized. The collaborative nature of this initiative may foster broader industry changes, emphasizing the importance of safety in battery development and shaping the future of electric mobility. As the 2024 implementation date approaches, the Blade battery stands to not only enhance the safety of electric vehicles but also set new benchmarks for the entire industry. Counterintuitive information in the content regarding BYD's Blade battery technology includes the following points. 1. Safety versus energy density. Traditionally, the electric vehicle EV industry has been driven by the pursuit of higher energy density in batteries, often at the expense of safety. This focus led to compromises, where batteries that provided greater energy capacity also posed higher risks of thermal runaway and fires. BYD's Blade battery counters this established norm by prioritizing safety alongside performance. This shift suggests that the industry might have overlooked safety as a fundamental requirement in favor of maximizing range and energy efficiency. 2. Performance under extreme conditions. The Blade battery's ability to withstand extreme conditions without igniting or emitting harmful substances challenges common perceptions about lithium-ion batteries. Many consumers equate high-performance batteries with inherent risk. However, BYD's design indicates that enhanced safety features can coexist with high performance, potentially leading to a safer EV market overall. This is a significant departure from the typical narrative that higher performance comes with higher danger. 3. Industry collaboration instead of competition. BYD's willingness to collaborate with other vehicle manufacturers to share Blade battery technology is contrary to the competitive nature often seen in the automotive industry. Companies typically guard their innovations closely to maintain market advantage. BYD's proactive stance in offering partnerships reflects a counterintuitive approach that prioritizes industry-wide safety improvements over individual corporate gain. For design efficiency, the Blade battery's design, which improves space utilization by over 50% compared to traditional batteries, challenges the perception that larger, more complex battery systems are necessary for performance. Instead, BYD's approach demonstrates that innovative design can lead to more efficient use of space without compromising safety or performance, suggesting that the industry could achieve better results through thoughtful engineering rather than just increasing size or complexity. 5. Misunderstanding of battery risks. The dramatic differences in thermal characteristics between the Blade battery and conventional lithium-ion batteries may counter common assumptions about safety in EV batteries. Many consumers may assume that any lithium-based battery carries similar risks, but the Blade battery's performance under stress indicates that not all batteries are created equal. This underscores the need for public education on battery safety and performance characteristics, which may not align with general perceptions. 6. Market dynamics and consumer priorities. The emphasis on safety featured in the Blade battery's development suggests a potential shift in consumer priorities. Historically, consumers have prioritized range and performance metrics. However, BYD's initiative indicates that as awareness of battery safety grows, consumers may start to place equal or greater importance on safety features. This could lead to significant changes in how EV manufacturers approach product development and marketing strategies. These counterintuitive elements highlight how BYD's Blade battery technology not only represents a technical advancement but also challenges existing paradigms within the EV industry regarding safety design and market competition. Important content overlooked in BYD's Blade Battery Technology Report. 1. Safety certification and testing methodology. Many reports highlight the Blade battery's superior safety features, but the specific methodologies and standards used for testing are often downplayed. BYD's rigorous testing approach, including the nail penetration test, is crucial because it directly addresses thermal runaway, one of the most significant risks associated with lithium-ion batteries. By documenting the temperature thresholds and reactions during these tests, BYD sets a precedent for safety certifications that could become the industry standard. This is significant because it not only assures consumers of the battery's reliability but also could influence regulatory bodies and safety standards globally, potentially leading to mandatory testing protocols that other manufacturers may have to adopt. 2. Market dynamics and competitive positioning. While the report mentions BYD's competitive positioning with the Han EV, it fails to explore how the Blade battery could impact the broader EV market dynamics. The significant investment in R&D, $1.2 billion, and the emphasis on safety could catalyze a shift in consumer preferences, prioritizing safety over merely range or cost. Other manufacturers who do not adapt to this new emphasis on battery safety may find themselves at a competitive disadvantage. This is significant as it could lead to a market where safety becomes a primary differentiator, reshaping how consumers evaluate EV options and potentially influencing sales across the industry. 3. Collaboration and industry transformation potential. BYD's expressed interest in collaborating with other manufacturers to share Blade battery technology is a crucial detail that may be overlooked. This willingness could facilitate a collaborative ecosystem where safety becomes a collective industry goal rather than a competitive edge. If BYD successfully engages with other automakers, it could lead to a widespread adoption of safer battery technologies, effectively transforming the EV battery landscape. This collaboration could also mitigate risks for smaller manufacturers that lack the resources for extensive R&D, fostering innovation across the board. The significance lies in how this approach could create a more unified industry standard, elevating safety protocols across all EV brands. 4. Environmental sustainability and lifecycle considerations. The report emphasizes the technological advancements of the Blade battery without sufficiently discussing its environmental impact and lifecycle. As the world increasingly prioritizes sustainability, understanding how the Blade battery performs in terms of materials sourcing, recyclability, and overall environmental footprint becomes critical. This aspect is significant because it aligns with global trends towards sustainable practices in manufacturing and product lifecycle management. BYD's ability to address these concerns could enhance its brand image and appeal to eco-conscious consumers, thereby influencing purchasing decisions and regulatory support. 5. Long-term economic implications. The report mentions the $1.2 billion investment in R&D but does not explore the long-term economic implications of this investment. This includes job creation in the R&D and manufacturing sectors, as well as potential economic benefits for local economies where production plants are established. Furthermore, as the Blade battery technology matures, it could lead to cost reductions in battery production, translating to lower prices for consumers and potentially accelerating the adoption of EVs. This economic analysis is significant as it frames BYD's innovation not only as a technological advancement but also as a catalyst for economic growth, job creation, and industry evolution. 6. Consumer education and market adoption. The importance of consumer education regarding the Blade battery's benefits is another area that deserves more attention. The transition to EVs is not solely a technological challenge but also a cultural one, requiring consumers to understand and trust new technologies. BYD's efforts to market the Blade battery's safety features effectively could play a crucial role in consumer adoption rates. This is significant as consumer perception can either drive or hinder the momentum of EV adoption, influencing BYD's market share against competitors that may not prioritize safety. 7. Impact on global supply chains. The report briefly touches on BYD's plans for production but does not delve into how the Blade battery technology could affect global supply chains. If the Blade battery becomes widely adopted, there may be a shift in demand for specific raw materials due to its unique design and performance characteristics. Understanding these changes is significant as it could influence everything from mining operations to international trade relations, particularly concerning countries that supply lithium and other essential materials for battery production. 8. Technological innovations beyond batteries. The focus on the Blade battery may overshadow other technological innovations BYD is pursuing. For example, advancements in battery management systems, integration with renewable energy sources, or improvements in vehicle efficiency could also be part of BYD's strategy. Recognizing these additional innovations is significant because they collectively enhance the value proposition of BYD's vehicles, potentially offering consumers a more comprehensive solution that addresses energy consumption, cost savings, and environmental impact. Conclusion. The overlooked aspects of BYD's Blade battery technology, including its safety testing methodologies, potential market transformations, collaborative opportunities, environmental sustainability, economic implications, consumer education, global supply chain impacts, and technological innovations, highlight the multifaceted significance of this development. BYD's approach not only represents a technological advancement but also a strategic shift that could redefine industry standards, reshape consumer expectations, and foster a more sustainable future for electric vehicles. Understanding these factors is essential for stakeholders in the EV market, as they navigate a rapidly evolving landscape influenced by innovations like the Blade battery. 1. Safety innovations in Blade battery technology. The Blade battery's design focuses significantly on safety, which is a critical concern in the EV industry. BYD's innovative approach ensures that the battery can withstand extreme conditions without igniting, a major advancement over traditional lithium-ion batteries. The ability to pass rigorous tests such as nail penetration and extreme temperature exposure positions the Blade battery as a safer alternative, potentially reshaping safety standards across the entire EV market. This emphasis on safety not only addresses consumer concerns but also encourages a shift in industry priorities from merely increasing energy density to prioritizing safety in battery design and development. 2. Strategic implementation timeline. BYD's structured implementation of the Blade battery technology in 4 distinct phases: R&D, pilot production, full-scale production, and market launch demonstrates a strategic approach to innovation. By 2024, the company aims to integrate this technology into its flagship models, starting with the Han EV. This phased rollout allows BYD to refine its technology, continuously ensuring that safety and performance benchmarks are met before full-scale production and market entry. Such meticulous planning highlights BYD's commitment to quality and readiness, potentially setting a new standard for how EV manufacturers introduce new technologies. 3. Investment in R&D and market positioning. The $1.2 billion investment in R&D signifies BYD's commitment to leading the EV battery market. This substantial financial backing not only supports the development of the Blade battery but also positions BYD as a serious competitor in a rapidly evolving industry. By combining safety, efficiency, and performance, BYD aims to capture a significant market share, especially as consumers become increasingly concerned about the safety and reliability of EV batteries. This investment strategy reflects a long-term vision that prioritizes innovation and sustainability, ensuring BYD remains at the forefront of the industry. 4. Potential for industry collaboration and transformation. BYD's willingness to share its Blade battery technology with other manufacturers indicates a proactive approach to industry collaboration. This openness could lead to broader changes in the EV battery landscape as safety becomes a shared priority among manufacturers. By fostering partnerships, BYD not only enhances its own market position but also contributes to a collective effort to improve battery safety standards across the industry. This collaborative spirit may catalyze innovations that benefit consumers and manufacturers alike, creating a safer and more efficient EV ecosystem. 1. Ford's Model T production and the moving assembly line 1913. In the early 20th century, Ford Motor Company revolutionized automobile manufacturing with the introduction of the moving assembly line. This innovation significantly decreased production time and costs, allowing for mass production of the Model T, which became the first affordable automobile for the average American. The assembly line's implementation involved critical phases: design of the assembly process, construction of the factory, pilot production of the Model T, and full-scale manufacturing. This transformation not only changed the automotive industry but also set new standards for manufacturing efficiency across various sectors. 2. IBM's development of the IBM System/360 1964. IBM's introduction of the System/360 was a pivotal moment in computing history. This family of computers was designed to cover a range of applications from small businesses to large institutions, and it marked a shift from proprietary systems to a more standardized computing platform. The implementation involved extensive R&D to develop compatible hardware and software, pilot testing with select clients, full-scale production, and a widespread market launch. The System/360 not only transformed IBM's business model but also laid the groundwork for modern computing standards. 3. Apple's launch of the iPhone 2007. The introduction of the iPhone by Apple Incorporated is a landmark case in the history of consumer electronics. Apple meticulously planned the launch through several phases: initial R&D to create a revolutionary touchscreen device, prototype testing to refine user experience, a controlled pilot launch to gather feedback, and finally the global market launch. The iPhone redefined mobile communication, integrating phone, internet, and media capabilities in a single device. Its success led to the smartphone revolution, altering the landscape of technology and consumer behavior worldwide. Future outlook: predictions for the implementation of BYD's Blade Battery technology by 2024. As BYD prepares to implement its Blade Battery technology by 2024, significant transformations are anticipated in the electric vehicle EV market and the broader battery technology landscape. The following predictions outline expected developments over the next few years. 1. Enhanced safety standards in the EV market. With the Blade battery's emphasis on safety, it is likely that industry standards will evolve to prioritize safety features alongside performance metrics like energy density. Other manufacturers may be compelled to follow suit, leading to the establishment of new safety benchmarks. This could result in a paradigm shift towards designing batteries that can withstand extreme conditions without compromising safety, influencing regulatory frameworks as well. 2. Acceleration of EV adoption. The Blade battery's superior safety profile may significantly boost consumer confidence in EVs, as safety concerns are often a barrier to adoption. The introduction of this technology could accelerate the transition from internal combustion engines to electric vehicles. The market may see an influx of new buyers, particularly in regions with stringent environmental regulations or growing public awareness of safety issues related to EVs. 3. Market competition and collaboration. BYD's willingness to collaborate with other manufacturers could reshape the competitive landscape of the EV battery industry. As discussions with various vehicle brands progress, partnerships may emerge that allow other manufacturers to incorporate Blade battery technology into their vehicles. This collaboration could foster innovation and lead to the development of new models that combine the strengths of multiple brands, enhancing overall market growth. 4. Increased investment in R&D. The $1.2 billion investment in R&D by BYD is likely to spur further innovation within the battery sector, as competitors observe the success of the Blade battery. They may increase their own research budgets to develop safer, more efficient technologies. This could lead to a wave of advancements in battery chemistry, design, and manufacturing processes, driving the evolution of the entire industry. 5. Expansion of manufacturing capacity. As BYD ramps up production in 2024, other manufacturers may also be motivated to expand their battery production capabilities. The growing demand for EVs equipped with innovative battery technologies could lead to increased investments in production facilities, particularly in regions focused on green energy initiatives. This expansion will be crucial to meeting the rising global demand for electric vehicles. 6. Geopolitical impacts on supply chains. The push for advanced battery technologies like the Blade Battery is likely to affect global supply chains. As countries strive for energy independence and sustainability, we may see shifts in sourcing materials and components necessary for battery production. This could lead to geopolitical tensions, particularly regarding access to critical minerals used in battery manufacturing, necessitating strategic partnerships and new supply chains. 7. Shift towards sustainable materials. The focus on safety and performance may also drive a shift towards more sustainable materials in battery production. BYD's advancements could inspire innovations in battery recycling and the use of renewable resources, contributing to a circular economy and reducing the environmental impact of battery manufacturing. This trend may also align with global efforts to combat climate change and promote sustainability. 8. Long-term cost reductions. As production processes stabilize and scale up, the costs associated with the Blade Battery and similar technologies are expected to decrease. Economies of scale and advancements in manufacturing techniques will likely lead to more affordable batteries, enabling EV manufacturers to lower vehicle prices. This reduction in cost could further enhance the competitiveness of electric vehicles against traditional gasoline-powered cars. 9. Increased focus on battery performance. While safety will be a central theme, the Blade Battery's development may also spark renewed interest in enhancing energy density and overall battery performance. As the industry shifts its focus back to optimizing performance alongside safety, we can expect innovations that improve battery life, charging speed, and overall efficiency, ultimately benefiting consumers. 10. Global expansion opportunities. As BYD successfully implements the Blade Battery, the company may look to expand its market presence internationally. With a strong safety record and competitive performance, the Blade Battery could attract interest from global markets, particularly in regions where EV adoption is on the rise. BYD's expansion could also encourage other manufacturers to enter new markets, further stimulating global EV growth. Conclusion. The implementation of BYD's Blade Battery technology by 2024 is poised to have far-reaching implications for the electric vehicle industry and the broader battery technology landscape. By prioritizing safety, collaborating with other manufacturers, and innovating in R&D, BYD could lead a transformative shift that enhances consumer confidence, accelerates EV adoption, and establishes new industry standards. As the market evolves, stakeholders will need to adapt to these changes to remain competitive and meet the growing demand for safe, efficient electric vehicles.